We are talking about a couple things today. We're talking about variable length arrays. I did briefly talk about it on Monday, but we're going to continue talking about it today. We're going to talk about omitting the size of the array. So normally when we would create an array, we need to say how big we want it to be, but there's a couple circumstances in which we can just say brackets and put nothing inside the brackets, and the size will be implicitly determined by the compiler. And the final thing we're going to talk about today is strings. So we talked about this before, briefly on Monday, but variable length arrays. So we can use a variable to determine the size of our array on runtime. So I could have an integer called a and set it equal to 9, and then I could say int my array of size a, and that will give me an array that looks like this. Remember that when we say when we declare an array and we give it a size, that means that we're going to have 0 through that number minus 1 positions. So on runtime, we can change the size of our array to be essentially whatever we want to. So just remember that we can, let's say I wanted to, I'll just go ahead and do an example here. Let's say we wanted to prompt the user for the size of the array. We could say scanf %i, store that in a, and then we could say int my array of size a, and that will give us an array give us an array of the size that the user specified. So I can fill that with I'll just go ahead and fill that with numbers. Yes, ideally you do want to use an array. There's a couple. I mean, you could theoretically do it without an array. No, you can't. No, you can't. You just can't. You theoretically could, but it'd be really stupid. It'd be really, really stupid. You can do, like, arrays are really just a grouping of different variables. And you could theoretically just have a million different variables that you're reading into, just one after another after another. But this is just the way you really want to do it in this case. Definitely. And then, so what this loop is going to do is it's going to loop from 0 up until the a that the user entered, and it's going to fill the array at position I with value I. And then what this loop is going to do is going to print out all these values that we just put in our array. Let's say printf %i space my array at I. So I want my array to be 10 big, so that's going to create an array that's 10 large and fill the array with 0 through 9. If you wanted to do, well, again, if you wanted to do 7 through 9, or you wanted to start somewhere not at 0, you'd have to say, you have to change this I. But let's actually do it a little bit differently. We can actually say I plus 5, let's say, and that will give us 5 through 15 instead. Or 5 through 14, off by 1. So the only reason it's 0 through 9 is because we're setting. Yeah, if you wanted actually 7 through 10, I would change this to I plus, or 7 through 10. So I'd want to add 7. Sure, I mean, you just have to change. It's all in your hands. Like, you have to write the program to accommodate that. But let's say I wanted numbers 7 through 10. So I would type in 4. And that would give me 5. I have to recompile it first. Type in 4, and that would give me 7 through 10. Because I have an array of size 4, and I am adding 7 to the index every time I run in. So at position 0, or in the first iteration of our for loop, I is going to be equal to 0, and we're going to say 0 plus 7, and then store that in my array at position 0. In the second iteration, I is going to be equal to 1, so we're going to say I, or 1 plus 7, which is 8, and then we're going to store it in my array at position 1, and that's how that's going to work. So a little more about arrays and variable sizing arrays. So just keep that in mind that you can change how big you want your array to be. So the only other thing we have to note is that we can only set the size of our array at declaration. We can't change how big our array is after we use it for the first time. So I can't say something like this. I can't say my array and then change the size. I can only set the size when I'm declaring it for the first time. So this right here does not work. All right, so omitting the size of an array. So remember, we can initialize an array with specific values like this. So we can say data type, variable array name, and then size in our brackets equals, and then bracket, and then numbers or characters, as a matter of fact, separated by commas. So in this case, we don't actually need to say the size of the array. We can just say what values we want to put in it, and the compiler will automatically determine the size. So if you see an array without any value specified here, that value is implicitly determined by how many items are in this list following the declaration.
So then let's say you do printf myArray 2. Would you get 4 then?
Yep, so this is position 0, that's position 1, that's position 2. So these two statements are exactly equivalent. It's just I want you to know that you don't necessarily have to use this number right here to declare the size of the array. That's completely optional if you tell the array exactly what values you want to have in it. Now, what you can also do is you can say myArray int 10 and then only declare 5 values. You don't have to declare all of the values if you want to say the size of if you want to say the size of the array. You can do something. Well, I don't want to right now. But you can, because this is at 0, that's 1, 2, 3, 4. But you could declare an array of size 10, and it would only declare these first 5 elements. Then the rest of the elements of the array would just be empty. So that is omitting the size of the array. So the big topic today we want to talk about is strings. So C doesn't actually have any specific type for a string. So in a lot of other languages, you would see when somebody's making a string, they'd say string. Their data type would be string. So instead of like remember that data types are things like int, char, float, double. Those are the data types that we talked about. And in other languages, again, you'd see string. But C doesn't actually have a string type. So in C, the only way to represent a string is with an array of characters, which it makes sense, I guess, because strings are realistically just a grouping of characters. But that does mean there's going to be a lot of things that we have to think about that we wouldn't necessarily think about when we'd be representing a group of characters. So in C, a string is really just an array of characters. So how would we actually get one? So to declare an array, to declare a simple string, we could say char myString array equals hello. So remember that if we omit the number here, it will just automatically determine the number from the string here. And that will result in an array that looks like this. All right. So we could also declare a string without any content. We could say char myString 5 with 5 positions. And this is actually off by 1. This should not be here. So in order to get this, I need to say 6. So, printing strings. So if I was to say myString hello, I could print that with printf, and then using the %s, format identifier in my format string and then by saying the variable name, or I could just say puts my string. So I'll just quickly demonstrate that. So that's an example of printing a string. Run program. So that will print the string hello. So again, you could go back and instead of saying printf, you could say puts, like we've done before, and we could say my string, and it will output your string. Run compile again. And that will also print hello. So that's two different ways that you can print strings right now. Remember that you can, with printf, you can specify multiple format identifiers. So you could print a string, and then you could put a space, a %i, and you could print a bunch of different variables in one spot. But just remember that we use the printf to print a string variable. So one thing that you might have noticed before is, in this example, our string, when we declared it hello, actually was actually of size 6, and it had something at position 5, and that is called a null terminator. So strings in C are null terminated. That means the last value is set to the literal value 0. So we can null terminate the string by saying my string and then the position that we want to stop the string at, and then set that to character \0. So why do we need to do that? So we need to null terminate our strings so functions like printf and puts know where to stop printing characters. So since in C strings are just a grouping of characters, we need a special character that tells functions that are using the string where the string actually stops. So think about it this way. So the algorithm for printing characters is like this. So we'd set next equal to the next character, and then we check if next is not equal to 0, then we're going to print next, else we're going to stop printing. So that's how strings pretty much work in all of the different functions that manipulate them. We don't have to pass in the size of a string like we would with an array or something like that, because remember, one of the things we had to do when we were passing, or one of the things you'll have to do when you're passing an array of integers or double or any other type is you'd have to say how big the array is so your functions will know how many elements are contained in that array. But with strings, all we have to do is set the last position of the string to single quote \0 single quote, and the functions that manipulate them will know where they stop. So strings building. So we can manipulate strings by setting individual characters. We can modify individual characters of a string just like regular arrays. So if I was to have the string my string hello, and then I was to set my string at position 0 equal to A, that's going to change the first position to A. So going back over here, I could do something like this. I can say my string at position 0 equals A. And then recompile it. And that will print this string instead of hello. And we can do that a bunch more times. We can modify that string however much we want. We could go and we could continue doing things like I could set all of the entire string to A. I'll do that really quick. I could be using different values here, but I'll just use A for now. So that will set the entire string to A. So the last point to keep in mind, though, is make sure that you don't override or forget the null terminator. So remember, the null terminator is usually at the last character, in the last position of our character array, and that's what stops, or that's what signifies the end of the string. So if I was to by accident say my string at 5, which at position 5 in this case, because we have 0, 1, 2, 3, 4, and then our fifth character, which isn't visible here, is the null terminator. If I was to override that, we may or may not get to see some interesting results. So no interesting results in this case. But as your programs grow more complex, and there's more variables inside them, you will get you'll get some interesting results. If all of a sudden your program's just printing garbage for just a bunch of garbage and it breaks a bunch of things, consider that you might have overwritten a null terminator, and that you might need to check that. So what might actually have happened in this case is there was another variable immediately after our array which contained the value 0. So nothing else is actually printed. But if there was other variables around, it might be different. So just don't do this because our array is only 5 big. Okay. So last thing I wanted to talk about, so we could also, instead of saying hello, we could actually say, we could give this a value. We could say with 5 positions, or let's give it 6 so we have room for the null terminator. And I could say my string 5 equals null. So I can actually build a string from scratch just by saying I have an array of characters and then setting each letter equal to a character value. So there we go. So that's how you would build a string completely from scratch. You don't have to set them in order. You don't have to set them to A specifically. You are really open to do whatever you would like. So any questions about strings, arrays in general, anything like that? All right, so then for today, our in-class assignment is as follows. So create 2 character arrays or strings of size 5. So read in 4 character values from the user in a loop. Assign the values to the first array in the order that they are entered. Assign the values to the second array in reverse order. So first character read, or the first character last, and the last character first. So hint, you should use, the loop that you use should have 2 indexes, so one starting at 0 and one starting at position 4, and then submit to day 29 in class. So I'll do an example up on the board.